will start. Yeah, okay. Hi, guys. So I welcome you all to today's session. Today is quantitative reasoning. This whole week we'll be doing quantitative reasoning in GRE live classes. Okay. So yeah, let's move forward. Our trainer would be Sir Delbin Marcos. Okay. And you need to keep these instructions in mind while taking the session. Please make sure you have a stable internet connection and a noise-free environment where you sit. And please use your earphones for the best experience, guys. Okay? Not only that, please do not write anything inappropriate in the chat box. Okay? Yeah. Moving forward, we have these three memberships: bronze, silver, and gold. In bronze, you get 4-week IELTS course, 1 AI validated mock test, usual university recommendation, free profile evaluation, counselor support. Okay? If you want to go for sectional tests, trainer validated mock tests, then you should go for the silver membership. You get the following facilities. And if you want to go for the one-on-one 20 hours IELTS coaching with the trainer, expert university recommendation, not only that, 5 mock tests as well, SOP, LOR, and visa facilities as well, you should go for the gold membership. Okay, we have this free profile evaluation that is done by our experts as well. It's absolutely free of cost and is available on our website. You get university shortlisting, course recommendation, country recommendation in this according to your future aspirations, career objectives, academic strengths, interests, and any of the requirements that you put in. Okay, and doubt clearance is done from A to Z, like shortlisting, application, scholarship, any of the doubt clearance you need is done in this. All of this is done for you guys, absolutely free of cost. So you should book your slot now, guys. We have these free live Duolingo classes that goes on from Monday to Friday, 6:30 to 7:30. And these are online classes, of course, and it's a 2-week course. You should enroll in this as well, guys. We have IELTS classes as well, Monday to Friday, 7:30 to 8:30. It's a 4-week course, okay? And we have 20 plus hours IELTS live classes, okay? And all of the recordings and handouts are available to you. Not only that, 20 plus classroom worksheets for your extensive practice is also available for you guys. Okay, so I'll tell you how to enroll in this as well. So guys, please do avail our application fee waivers and many more elite features along with expert counseling. Do reach us now. All of our contact details are available on our website, ubergrad.com. Okay, so guys, we have this Ubergrad webinar that will take place this Saturday, that goes on from 7, and it will be taken by our co-founder, Mr. Jaideep Gurujala. Okay, so you guys should join this webinar as well, because this will be very beneficial for you all. In this webinar, we will be discussing about how to write a perfect SOP LOR for masters in abroad. Okay, and all of the points listed here will be discussed. Okay, so I will just share the I will share the link in which you can go and register yourselves very quickly. Okay, so it'll be very easy for you all, guys, and it'll be a very interesting session. So please do join. Okay, I'll yeah, I have sent the link in the chat box. Please go and register yourself for this, guys. Okay, thank you. These are a few reviews that we've gotten. Okay. Yeah. Moving forward, guys, this is our homepage, ubergrad.com's homepage. Okay. You go on solutions, you go on free profile evaluation, you land on this page. And over here, you can book your slot according to your date and time feasibility. Anything you want is available over here. Okay. You can book it now. Okay, moving forward, you come back to the home page, you go on solutions again. These are our store courses: live IELTS, live GRE, live Duolingo. You can go and enroll in these classes as well. And after that, you'll start getting the links for the classes. Okay, moving forward, guys, we have these education loans as well. You can go and search in our additional services. Not only that, you can read about the many blogs and articles that are posted for you all, okay, to gain more knowledge. Okay, moving forward, go and explore. And for example, you want to know about GRE or IELTS or TOEFL or any other. Like for example, we take GRE. Click on all about GRE and you will land upon this page. Okay. All of the details of GRE are given over here. See, from overall, okay. See, overall details. Okay, come back up. Analytical writing details, quantitative reasoning details, and verbal reasoning details. Okay, all of them, guys. You can gain all the knowledge from our website only. Okay, so yeah, That's that. Okay. I think this is it from my side, and I'll just hand over the session to Sir now, and he'll take over. Yeah. Sir, are you there?
Yes, yes. Am I audible, ma'am?
Yes, yes, sir. Good evening, sir.
Good evening. Am I audible to everyone? Perfect. Okay. So today we are going to cover numbers. It's one of the important topics we have it for the exam. Last class we have covered exponents, right? And we discussed it. We will get 2 to 3 questions for the exponent topics for our GRE exam. Out of 40 questions, you will get 2 to 3 questions from the exponent. Now we are going to cover today and next class will be numbers. It's one of the important topics. We will get approximately 4 to 5 questions. Okay, 1 second. Yeah, 4 to 5 questions from the numbers chapter. Okay, numbers class, we will cover numbers today and tomorrow also. In today's class, we will cover what is factors, multiples, divisors, prime factorization, HCF, LCM. So 30 to 35 minutes, we will cover the theory. Once we're done with that, like last time I said, once we're done with that, we will solve the official middle questions, which is related to numbers. That way, your preparation will be more accurate. You can save lots of time. Okay. Now, tomorrow we'll cover cyclicity concept, divisibility concept, rounding off, reminder concept, and we will have a doubt clearing session also about numbers, exponents. If there is any questions, you can ask at the end of tomorrow's class. Now, let's start with numbers here. Yeah. Okay, let's start with numbers here. If there is any technical issues from my side, please inform me. Okay, you can type it in the chat box or you can speak. Okay, let's continue. Numbers. Numbers are divided into two categories, real numbers and imaginary numbers. But for our GRE exam also, GMAT exam also, we don't need the imaginary part. So we are not going to discuss about imaginary part. And real numbers are divided into two groups, rational numbers, irrational numbers. Okay, rather than going like this, let's go in a different way. Okay, now let's say what is a natural numbers. Let's say natural numbers means counting numbers, right? So we can say 1, 2, 3 like this. Now, if I bring 0 in front, 0, 1, 2, 3, we will say this as a whole number. Okay. Now, what about integers? For example, you can say 1, 2, 3. It can be 0, negative numbers also, -1, -2, -3. Okay. Now, this is called integers. Now, the real numbers is divided into two groups, rational numbers and irrational numbers. The rational numbers can be divided into integers, whole numbers, natural numbers. You can see 1, 2, 3. This is rational numbers. This is irrational numbers. Let's focus on natural numbers 1, 2, 3, and whole number. I just brought 0 here. So we can say all natural numbers are whole numbers. And we know that integers means like 1, 2, 3, and negative part also have to consider. So we can say all whole numbers are integers. All natural numbers are integers here. Now let's focus about rational numbers and irrational numbers. Rational numbers means you have to write it in this form, P by Q form, where P and Q must be integers and Q should not be equal to 0. What happens if Q is 0? Then you know that P by 0, right? When you're dividing a number by 0, it's not defined. So P and Q, that should be an integer. If you can write any numbers in the form P by Q, that will be rational numbers. If I cannot write the numbers in not in P by Q form, that will be irrational numbers. And P and Q should be integer. For example, let's say, can I say 7? It's a rational number? Yes, because I can say 7 by 1, P by Q form, and both of them are integers here. Okay. What about 0.10? Yes, this is also rational numbers because it's ending, or in other words, you can say P by Q form. You can say 1 by 10. Both of them are integers here. Is this clear? So we can say all integers are rational numbers, all whole numbers are rational numbers, all natural numbers are rational numbers. Now, what about, so I hope it makes sense to everyone, okay? And what about if you are getting something like this, 0.333? Guys, is this a rational number? 0.333. Yes or no? Is it a rational number? Something repeating, 0.333. Please type your answer, yes or no. I'm no, So guys, you are saying 0.333, it's not rational numbers. It is rational numbers, okay? Remember one more point, okay? Don't think this also, repeating decimal, that is also considering as rational numbers. So repeating decimal, that will be also rational numbers. So if I say precisely non-terminating repeating decimal, so let's keep this way, repeating decimals. 0.333 is what? 1 by 3. Clear? So it's already P by Q4. So when you are getting any numbers, what you have to do, is this number entering? Then it's rational number. Second thought process, is this number repeating? Then it will be called rational numbers. What about here, if you're getting an expression 0.125125? Is this a rational number? 0.125 or 125 like this. It keep going like this. Is this a rational number? Is this a pattern repeating? Check it. The pattern is repeating, right? So they will say like this, right? 0.125. Is this pattern repeating? Yes, it's keep repeating like this. So definitely this will be a rational numbers. I hope it's clear to everyone. Okay. So when you're getting an example, okay, for example, zero point 0.7 or for example, let's say 0.7, we know that 0.325, it's ending. Definitely I can say it's a rational number. That's enough. And if you are getting the repeating pattern, for example, 0.222 like this. Okay, I know that it's not ending, but I know same number it's repeating, or we will say repeating decimal, same numbers repeating, right? A pattern is repeating. So it will be also rational numbers. Okay, now what about irrational numbers? If I put it in the calculator, square root of 2, okay, so I will say exactly the square root of 2 value. That will be, you see, this is the square root of 2 value, 1.41421 It's keep going like this. Is it ending? No. Is it a repeating decimal? The pattern is not repeating. So definitely this will be an irrational number. Okay, you do the same thing, square root of 3. Okay, same thing. This number, it's not ending. Then the second thought process, is it repeating decimal? No, it will not. So it will be an irrational number. Guys, is this clear? What is irrational numbers, rational number? They will not ask you like this. Okay, but you need to know what is natural numbers, whole numbers, integers like this. Please, everyone, is this clear? Okay, perfect. Now I will give you two examples. Please try to do it faster. First and second question. I hope everyone can see the questions. Okay. So rational means we know that P by Q form, or you can think in other way, right? Is it ending? Okay. If second one, if it is not ending, is it repeating pattern, repeating decimal? That's what you have to think. Okay. Now, if I cannot write these two ways, definitely it will be irrational numbers. Okay. Everyone said, see, that's perfectly fine, which is not rational. So it will be irrational, right? So I should not write P by Q form. 3 by 1, that's exactly 3. That you can say as an integer. Integer will be in rational, or you can say P by Q form. This is a rational one. 0.333. So please do not say it's an irrational one. It's called repeating decimal. 3, it's again repeating, right? Or you can say that's 1 by 3. So this will be also rational. 1.3, it's ending. If you want to think, you can say 13 by 10. It's P by Q. Both of them are integer. It's ending. That will be rational. Square root of 3, you put it in the value in the calculator. It's not ending and it's not repeating. So this will be the answer. What about the second question? Faster. Which of the following is not irrational? So it means rational, they're asking. So I have to write it P by Q4. Yeah. Okay. Correct, Bowen. So what about others? Yes. SI, that's right. Curly, that's right. Okay. Now, only one answer, right? Square root of 4, that will be 2. Square root of 2, you are not getting repeating decimal. It's keep going like this. Square root of 3 also same. It's not ending, and different values you're getting same thing. Square root of 5. Okay, it's not ending, it's a different value. So here I already got it. Square root of 4, that's 2, or you can say 2 by 1, it's P by Q form, or it's ending, that will be rational numbers. Okay. Now, another key point here, even numbers. If I ask you a simple question, is it 6? It's an even number. Yes, you will say it's an even number, because when you divide by 2, you have to get an integer value, or there should not be no reminder. What about 7? Is it an even numbers? You divide by 2, it's not an integer, or you're getting reminder. So 7, it's 7, it's an odd number, or I can say it's not an even number, right? So my question is, it 0 is even or odd? What is your answer? Is it 0 is even or odd? Yes or no? Please type your answers. Is it 0 is an even number or an odd number? Okay, guys, please try to remember 0, it's an even number, okay? This will be useful. So what is the definition of an even number? Let's say 6 is an even number. How you did it? You just divided by 2. And if you are getting an integer, that will be an even number. So same rule we are going to apply. 0, it's an even number. You divided by 2. What is the result you are getting? 0. What about 0? Is it an integer? Yes, we know that integer means, for example, -1, 0, 1, 2 like this. So it's an integer. So 0 by 2, you are getting 0. That's an integer. Definitely 0. It's an even integer. For example, if the question is like this, number of even integers from -4 through 4. So you have to consider -4, -2. Then you have to consider 0. That's an important point. Then 2, 4. Do not say these two, these two. That will be 4 even integers from -4 to 4. That will be just 5 options. Is this clear? This statement is clear. So there will be 5 even integers from -4 to 4 here. Okay, if you're not understanding, please let me know. The second thing, what about 0? Is it positive or negative? No, it's neither positive or nor negative, right? So if I consider a number line 0 here, all the positive number this side, all the negative number this side. So 0 is here. So 0 is not positive and not negative also. Perfect. Now, this already we discussed it here. Now, this is the key important for part of this class, and you will get a difficult question typically from here. Okay, factors, multiples, divisors, divisibility. Okay, let's try to discuss multiples. So if I ask what are the multiples of 7, okay, let's focus on multiples. Look, factors, divisors will focus after 2-3 minutes. It's the same meaning only, factors, divisors. Multiples, divisibility, we can say in the same way. So if I ask you multiples of 7, okay, we have a tendency to say 7, 14, 21. We will not say -7. Remember, multiples can be positive also, negative also. Clear? Please try to remember that. So multiples of 7 means all the multiplication of 7. You can say 7 times 1, 7, 7 times 2, 14, 7 times 3, 21 here. Same thing, you can say 7 times 0, that's 0. 7 times -1, -7. 7 times -2, that will be -14. So multiples of 7 means you have to consider both direction, positive also, negative also. Multiples of 7, 7, 14, 21 going this side. That will be 7 times 1. Here 7 times 2, 7 times 3. Here 7 times 0, that will be 0. 7 times -1, -7, -14. Is this statement clear to everyone? Do not think multiples always positive. It will be negative also. Can you confirm? Is this statement clear to everyone? Okay, good, good, perfect. Now, we are going to discuss the factors and the divisors, okay? It's the same meaning. Remember, factors, divisors, same meaning. So if I ask you a simple question, what are the factors of 12? What will be the answers? How many factors we have it for 12? Or what are the factors of 12? What can be the factors? So factors, okay. Can I say 2 is a factor of 12? How do I know that? Can I divide 12 with 2? Yes. If you are getting an integer, that will be a factor. There is no reminder. That's the definition of factor. A factor of a number is the number that divides the number completely, means there is no reminder. Okay. Now, can I say 5 is a factor of 12? Can I say 5 is a factor of 12? Correct, Uli. Lucky, that's correct. 1, 2, 3, 4, 6. Now, 5 is a factor of 12? No. When I divide 12 by 5, it's not an integer value. You are getting some decimal values, right? So this is not a factor. So we understood what are the factors of 12. We can say 1, 2, okay. 12 divided by 1, it's an integer. 12 divided by 2, that's an integer. 12 divided by 3, that's an integer. So we can say 3 is a factor of 12. I know that I can divide by 4, I can divide by 6, I can divide by 12 also. So this many factors for 12, that will be 6 factors. They can ask the same question. They can say divisors of 12. It means factors of 12. It's the same meaning only. Okay, what are the factors of 28? Same thing, you check it one by one. And can I divide by 1? Yes. 28 by 1, it's an integer value. 28 by 2, it's an integer value. So 2 is a factor of 28. Can I say 28 divided by 9? 9 is a factor of 28, or 9 is a divisor of 28? No, you are not getting an integer value. We are getting a decimal value. So definitely 9 is not a factor. So I hope this theme is also clear. Okay. Now, I will show you one question. 1 second. What is the answer for this question? how many different integers are factors of 10? So there are four answer choices I have given. Okay, 3, 4, 5, 8. Please type your answers. Okay, I got B. What about others? C. Okay. Whoever got C, check it one more time. I don't think so. It will be C. Okay. Lucky Murli, you missed 1, 2, 5, right? Only, but you missed 10. Now, look. So if you look at the chat box, you can see, yes, Bhuvan, you're right, Bhuvan. Correct. Okay, only one person said 8. Everyone said it's 4. It's not wrong. Okay, but you have to look at the words. We have a tendency. Remember, factors, multiples. Please do not think only positive numbers we are considering. You have to consider the negative also. I will explain in details. Okay. Now, integers, right? You see the, okay, I will just show you a different question. Look, they said positive integers means positive numbers only you have to consider. Here they said integers, right? So integers means it can be negative number also. For example, -2, -1, 0, 1, 2, 3, like this, right? These are integers. Positive means 1, 2, 3, like this. Clear? So you have to start looking at the words. Integers means you have to consider positive also, negative also. For example, okay, everyone is right. You said 4, but there is a careless mistake. These are positive factors. Start noticing this. Okay, 10. I can divide by 1. So 10 by 1. So 1 is a factor of 10. I can divide by 2. Okay. 10 by 2, you are getting an integer, right? Can I say 3 is a factor of 10? 10 by 3, you are not getting an integer value. 3 point, I think some decimal value you are getting. Okay, so 3 is not a factor. Try 4. No, 4 will not work. Try 5 and 10. Yeah, that's how you got 4 options. Okay. Now, what is the definition? Okay. And for example, can I say -2 is a factor of 10? Same thought process. How do I say 2 is a factor of 10? You divide it by 2, you are getting an integer. Same thought process. Negative number also. You can I divide 10 with -2? So 10 divided by -2, what you are getting? -5. Is this an integer value? Yes. So that's an integer value. So if you are getting an integer value, remember that can be also factor. So whatever that positive factors, you have to remember negative also. 1, -1, -2, -5, and -10. Clear? So if you look at the question carefully, how many positive integers are factors of 10? Exactly 1, 2, 5, 10. If they said how many integers are factors of 10, you have to consider the negative number. Or you can think this way, the positive factor was 2, 4. Okay. So how many negative factors will be there? Same number 4. You can say 4 times 2, or whatever the positive factors times 2, that will be. Okay. So is this clear to everyone? Is this clear? So all you have to think, look at the word. Are they saying positive integers? Are they saying negative integers? If it is not clear, please let me know. So factors means you have to consider positive, negative, multiples also. Devices means it's the same meaning only, right? If it is not clear, let me know. I can explain one more time. Please, anyone struggling, please let me know. I can explain it. Okay, I hope everyone understood this one. And I wanted to go through this statement. This is from the official guide, okay? Just go through it. Do you understand the meaning of this statement? Just read it from here to here. This is from the official guide. If you understood, please confirm it. Can you say yes or no in the chat box? I hope everyone can read, okay, what is written there. Is this statement clear to everyone? So all they're trying to say, factors, multiples. You have to consider positive also, negative also, not only positive. That's a one mistake students used to do. Okay. That's what you have to understand. Please, everyone, confirm it. Okay. So let's say, what are the factors of 40, right? So for example, yeah. So I can say I can divide by 2, not only 2, I can divide by -2. Can I divide by 5? Yes. Not only 5, I can divide by -5. So how there is a shortcut, how many factors we have for 40, that we'll discuss it after 10 minutes. But I hope you understood factors means it can be positive also, negative also. Start looking at the word. Is it positive integers or is it integers given? Okay. Multiples of 7 means 7, 14, 21. I can go backwards, -7, -14 like this. So I hope this statement is clear. Okay. So I hope everyone can identify the difference between these two questions, right? How many different positive integers are factors of 441, right? Now look, these are the positive factors. I think 3, 4, 5, 6, 7, 8, 9. So 9 positive factors. Okay, 9 positive factors. If the question was like this, how many different integers are factors of 441? Same thing, whatever the positive number, you have to consider negative. -1, -3, -7 like this. So here 9 positive factors, then 9 negative factors. Overall will be 9 times 2, that will be 18 factors, if that was the question. Okay. Now here they are specified how many different integers. So we are considering both positive and negative. But for GMAT, I see this type of questions. Okay. But for GRE, they will say positive integers. But it's already mentioned in the official guide, so we cannot skip it. So I have to explain it also. Okay, good. Now look at this statement. Um, these are the 4 different ways. This is the maximum way they can frame a question. They can say X is a factor of Y. For example, let's look at this statement together. We know factors, divisors, same meaning. Multiples, divisibility, same meaning, right? Let's say if you got a statement, if X and Y are integers, and they said X is not equal to 0. Okay. And if, okay, let's say you got an expression. It's the same expression, X is a factor of Y, X is a divisor of Y is a multiple of X, Y is divisible by X. Should I need to write it Y by X is an integer value, or X by Y, it's an integer value? Let me say this is the first option, this is the second option. For this particular one, how I should write? Y by X, it's an integer, or X by Y, it's an integer. Same thing only, same meaning only. These are the 4 ways they can frame the question. Which statement is true? Is it first statement or second statement for these 4 options? Yeah. 2. Okay. Kumaran, just try to think. Okay. See, this is, yeah. Everyone can type the answers. That's perfect. Please try to type the answers. Okay. Now, Kumaran, look at here. Okay. How do I read this statement? 10 divided by 2, you know that you are getting an integer. So if I read it factors and divisor, we will say 2 is a factor of 10. Okay. 2 is a divisor of 10. Clear? We will not say 10 is a factor of 2, 10 is a divisor of 2. That is wrong. So what you have to do, if they are saying X is a factor of Y, X is a divisor of Y, right? It's the same meaning. Always the small number will come, friend. You can write like this: 2 is a factor of 10. So how do I write it? 10 by 2, it's an integer, or 2 by 10 an integer? Now 2 by 10, it's wrong, right? So 10 by 2. For 10, I have to put Y, and for X, I have to put 2, right? So this is 2, Y by X. So for a difficult question, this will help you to save a lot of time. So Kumaran, is this clear? Why it's not option a second? So how we read it, this statement? 1 second. Yeah. So 10 divided by 2, we read it. 2 is a factor of 10, and 2 is a divisor of 10. What about divisibility? That's very simple, right? That will also make sense. We can say 10 divided by 2. If you know that that's an integer, 10 I can divide by 2. So that's called divisibility, right? 10 is divisible by X. 10 is divisible by 2. 10 is a multiple of 2 here. So please try to remember what is the meaning of this 4 statement. Y is a multiple of X. Please do not write X by Y, it's an integer. Y by X is an integer here. So we can think like this: Y is a multiple of X. So you can think like this: 10 is a multiple of 2 here. Or Y is divisible by X. You can say 10 is divisible by 2. And where should Y go? Of course, the numerator part where it is 10, 10 by 2. So an X will be the smallest number, 10 by 2, it's an integer. I hope this 4 statement is clear to everyone. If it is not clear, you can just go to the recorded video and please watch it. If you didn't understand, please let me know. In the next class we can discuss it. Okay. Now common positive factors, right? From the, what is the meaning of common positive factors? We know factors. You have to divide the numbers completely. Positive factors, we know common. For example, 8, 12. If I write all the factors of, okay, 8 and 12, what about 8? Factors can be 1, 2, 4, I think 8. What about 12? 1, 2, 3, then I think 4, 6, 12. So what are the common factors? 1, 1, 2, 2, 4, 4. I think that's it. So all I know, these are the common factors, 4, 2, 1 here. And you can see common positive factors of 30 and 42. I have written everything. Common factors will be 1, 2, 3, 6, 1, 2, 3, 6 here. You can write, what about the question like this? Common multiples, right? We know what is multiples and you have to take the common. So multiples of 3, you write all the multiples of 3, 3, 6, 9, 12 like this. Same thing, multiples of 4, 4, 8, 12. Now, what are the common things coming? 12, 24, 36. So I hope it's clear what is common positive factors, common multiples here. From the word you can understand. Now let's talk about prime factors. Prime numbers. Prime number means any positive integer which has exactly two distinct positive factors. And can I say 2 is a prime number? I can divide by 1 and I can divide that number by that number itself. What about 3? Is this 3 a prime number? Yes, I can divide by 1. I cannot divide by 2. I can divide by 3. 1 and that number itself. What about 4? Is it 4 prime number? Definitely, I know I can divide by 1. I can divide by 4. I can divide by 2. No, this is makes sense, but this is extra. I cannot say 4 is a prime number. Okay, so you have to remember certain at least up to 20. What are the prime numbers? 2, 3, 5, 7, 11, 13 like this. What about guys 6? Is it a prime number? I can divide by 1, 2, 3, 6 like this. These are not prime numbers. You have to divide by 1 and that number itself. So there is only one even number that is a prime number, that is 2. Clear? Any number 6, 8, all these things, definitely I can divide by 1 and that number itself, and I can divide anyway with 2 here. So only one even number as a prime number. And guys, one more mistake. Students used to think 1 is a prime number. No, 1 is not a prime number. The definition, you have to have only 2 factors, 1 and the number itself. Okay, what are the factors of 1? That will be 1. That's it. Only one factor we are getting. So 1 is not a prime number. Is this statement clear to everyone? Prime numbers? Please confirm it. Yeah, okay. Now, another concept, okay, I have to cover lots of concepts here. Now, prime factors. From the word, try to understand. Factors we know, prime number we know. So just combine it here. So the prime factors of 15, right? So what you have to do, any number, let's say you got 15. You have to write it as the product of prime numbers. Prime numbers we know 2, 3, 5, 7 like this. So 15 means 5 times 3. So what are, okay, let me just write from the, okay, 1 second. Let me just explain a little bit neater here. We know that prime factor means a factor that is a prime number. What are the factors of 15? That will be 1. Yes, yes. Okay, lucky 2. Okay, 1 second. Prime factors, right? I'm just asked here 15. So what are the factors? A factor that is a prime number, I can divide by 1, I can divide by 3, I can divide by 5. Factors I'm writing here, then I think I can divide by 15. That's it. Yeah, 4 options. So from here, 1, 3, 5, 15. How many prime numbers are there? 3 and 5. That is a meaning, okay? So what are the prime factors of 15? That will be 3 and 5. What about here? What are the prime factors of 12? What will be the answer? Prime factors of 12. So you have to think, write all the factors. Out of this, how many prime numbers are there? That will be prime factors. Try to write all the factors of 12. Okay, I think that's true. Yes, everyone. Okay. So factors, I will start with 1. There is an easier way which we can discuss it later. Look, 1, 2, 3, I think 4, 6, then 12. Okay. So from here, how many prime numbers? 2, 3. That's the answer. 4 is not a prime number, 6 is not. So 2 and 3, that will be the answer. So prime factors also, we discuss it here. Now, another technique called prime factorization, okay? They will never ask what is prime factorization for the exam. But if you know prime factorization, you can solve the HCF and LCM in an easier way. HCF and LCM in an easier way. There are 2 ways you can do prime factorization. You have studied in school, either factor tree method or division method. Whatever the method you're comfortable, just apply it. But I'm just going to discuss both the questions. So what is a prime factorization? The process of writing a number as the product of prime numbers. Okay, that's called prime factorization. From the word you can see prime, and if you are factoring it here. So you, let's say prime factorization of 18, it means you have to write it as a product of prime numbers here. There are two ways you can do: tree method and division method. I will just discuss both the approaches, then you can follow whatever the approach you are comfortable. Let's focus on tree method. Okay, what is tree method? You consider what is a prime factor of 16, right? Sorry, a prime factorization of 60. You write 60 as the product of any two numbers. There are different ways you can write 10 times 6, or 6, maybe I think 20 times 3, whatever it is, right? So let's write 10 times 6. Is it 6 is a prime number? No. Is it 10 is a prime number? No. Then again divide, you have to get a prime number at the bottom, like 2, 3, 5, like this. 10, I can say it as 2 times 5. Okay, 2 is a prime number, 5 is a prime number. I can stop it here. What about 6? 6 is not a prime number. Again, break it. 3 times 2. Is it 3 is a prime number? Yes, 2 is a prime number. So what is 60? 60 will be, it's a multiplication of everything. 2 times 5 times 3 times 2. If I write it in the exponents way, 2 square times 5 times 3. Okay, this is 15. 15 times 4, that will be 60. Is this clear, the tree approach? For example, if you write it as 60, 20 times 3, any number you consider, 3 is a prime number. What about 10? Sorry, 20, it's not a prime number. I can think like this: 10 times 2, or 5 times 4, whatever the way. So 2, I know it's a prime number. What about 10? No, I can still break it 5 times 2. And there is a 2 here, there is a 3 here. It's the same answer. Is this clear to everyone? What is a factor tree method? Please confirm it. Okay, perfect. So if you are comfortable with this way, actually the factor tree method is a little bit easier. Okay, let's say if you're really struggling it. So what I will say, that's called, then you can use prime factorization method. So let's consider 60. Okay, 60. The idea will be the division approach only, but you have to divide by a prime number always. You can divide by any prime number first, 2, 3, 5, like this. Please do not divide by 4 or 10 like this. So 60, let's divide by 2 or 3. If I divide by 2, 60 divided by 2, that will be 30. Again, 30 I can divide by 2. 30 by 2, 15. Okay, again bracket, I think I can divide by 5 or 3, perfectly fine. So 15 by 5, that's 3. Again divide by 3. The idea will be you have to get 1 here. So what is 60? You can say it's a product of all these numbers. Okay, 2 times 2 times 5 times 3. Clear? You can apply this approach. At the end here, we have to get 1 here. Is this clear? This division approach, division method, please confirm it. Okay. Now, one question I'm going to do it. Okay, you will get this slide also. 144. You have to pick. You have to write it as the product prime factorization. You have to do it. What will be the answer? So you can do two ways. Let's do this question. Same thing only. 144. You have to write it as the product of. You have, yes, prime numbers. You can apply division method or factor tree method. What will be the answer? Any approach. Just follow one approach. Which options? Okay. Let's take 10 more seconds. Yeah. Yes, everyone is getting option A. That's right. Okay. One approach only you have to use it. Factor tree method. If you're comfortable, use that. Division method. Division method is a little bit lengthier, but if you're struggling, just do that way. That will be easier. Factor tree method. Let's see factor tree method. 144. You have to multiply by two numbers. It's up to you. I think my mind, I'm getting 12 times 12. 12, it's not a prime number. So I again bracket 4 times 3. Okay. So 4, it's not a prime number. So I can say 2 times 2. And you have to remember 3. Same thing, right? 12 means 4 times 3. Again, 4 is not a prime number. I can break it as 2 times 2 times 3. So 144, you can say 2, we are, so product of these numbers, correct? 2, we are multiplying 1, 2, 3, 4. That will be 2 raised to 4. And if I look 3 here, I'm multiplying 3 2 times. 2 raised to 4 times 3 square. That's option A. If you're going for the division method, 144, one time I will solve this question faster. Can divide by 2. This will be, I think, 72. Again, divide by 2. 72 by 2, that will be 36. I think you can divide by 3 or 2. That will be, if I divided 18, again, let's divide by 2. That will be 9. Again, divide by 3. Divide by 3. And here it's 1. Okay, I can stop it here. Now you see, 144, it's a product of all these numbers. 2 times 2 times 2 times 2, that will be 2 raised to 4. And 3 times 2, that will be 3 square. So I hope prime factorization is clear. Now let's talk about HCF. They can say HCF, GCF, or GCD. It's the same thing. From the word we can understand. But remember, for our GRE exam, they will not ask you to directly find the LCM of this number or HCF. They will put it as a word problem. So you have to identify it's an HCF concept or LCM concept. We'll discuss the official question, so it will be clear for us. But before that, let's try to understand. HCF, right? You know the word factor, you know the word common, and you have to take the highest. That's it. Even if it is GCF, here for the highest, they're using the word that's it. Factor, that should be common, that should be the greatest here. For example, if I ask you a simple question, what is the greatest common factors of 12 and 16? I've written all the factors of 12, 1, 2, 3, 4, 6, 12, and factors of 12, 16, 1, 2, 4, 8, 16. So we understood all the factors. Now you have to consider the common factors for 12 and 16, 1, 2, 4 here. You can see 1, 2, 4 here. Now, okay, I did all the factors. I did the common. Then you have to look what is the highest factor here for all the expression. That will be 4. So what is the HCF of 12 and 16? That will be 4. Is this clear? What is the meaning of HCF? Please confirm it, yes or no. Factor, first find the factor, then look at the common factors, then you have to take the highest one. Everyone, please confirm it. Okay, please others. Type yes or no. Okay, I hope it's clear to everyone. Now, what about if I get a bigger number like this, 136, 512, or anything like this, okay? Even if it is 3 numbers. So that time, if you write it like this, it's a waste of time. You are going to consume lots of time. So what you can do, if you're getting like big numbers, you can just use the prime factorization techniques. Clear? So we know that GCF or HCF factor, that should be common, that should be the highest here. So you can use division method. So what we are trying to do, by what number can I divide all these numbers maximum? That will be the idea. Okay, so we got 24, 48, 60 anyway, and make sure that it's prime numbers. That's one thing you have to be careful. Okay, let's try to divide. Can I divide everything with 2? Because 2 is a prime number. 24 by 2, that's 14. 48 by 2, that's 24. 60 divided by 2, that will be 30. Okay, I understood. Is there any common number I can further divide? Is there any common number I can further divide all the expression? Yes, I can go again with 2. 14 divided by 2, that will be 7. 24 divided by 2, that's 12. 30 divided by 2, that will be 15. Okay, now look, can I divide all these 3 numbers with a prime number? Yes or no? Guys, I made a mistake, okay? Then no. Can you find out what was the mistake? I written 24 by 2, that's 14. This is wrong. Yes, Satya, you're right. I made a mistake. Please pardon me. Please correct me if I am making a mistake. Yeah, right. First, let's divide by 2. This is 12. This is 24. This is 30. I've written 14. Okay, that was mistake. So again, I can divide by 2. That will be 6. This will be 12. This will be 15. Now look at here. Can I divide by any prime numbers here? Yes, 3 only, right? So it will be 2 here. This will be 4. This will be what? 5. Okay, I cannot divide it with a common number. So what will be the GCF? Whatever the numbers you divided, everything. So GCF of this number will be 2 times 2 times 3. Clear? That will be the answer. 6. 6 times 2, that will be 12. Is this clear, the approach? So the product of all the common numbers. Is this clear? For a bigger number also, how to do that? Okay, maybe let's try to do this question 12 and 16. Let's use the ladder technique, right? Or the division techniques. Can I divide by a prime number? Yes, 2. That will be 6. This will be 8. Can I further divide these 2 numbers? I think I can divide by 2. This will be 3 and this will be 4. Can I further divide? No. So what will be the GCF of 12 and 16? The product of these two numbers, 2 times 2, that will be 4. Okay. So bigger number, you can do that way, division techniques. Okay. Now let's talk about LCM. Please look at the word multiples, that's common, least, lowest, right? So if I ask you a simple question, what is the LCM? Let's try to understand the reason here. Find the least common multiples of 4 and 6. You write all the multiples of 4. 4, 8, 12, 16. Yeah, it's 20, 24, 28. It's keep going like this. I think 60, I can write it. So here, multiples of 6, 6, 12, 18, then 24. It's keep going like this. Now I know the multiples of 4 and 6. What are the commons? 12 coming, 24 coming. It's keep there are lots of common numbers here, correct? Now what will be the lowest common multiple? That will be just 12. So the LCM of 4 and 6, that will be 12. Is this clear? What is the meaning of LCM? Now, what about if you get a number like this? What is the least common multiple of 6, 8, 9 here? Then it will be difficult to write all this thing, right? Multiples of 6, 6, 12, and 18 like this. Multiples of 8, 8, 16 like this, and multiples of 9. Okay. So what is the best approach? If it is not a simple number, just use the division approach. Okay. So same logic here, the way we did it. Let's do 6, 8, and 9 here. So the idea will be you don't have to divide everything. Here at the end, you have to get 1, 1, 1. So you can divide by any prime number. Let's divide by 2. 6 by 2, that will be 3. 8 by 2, that's 4. 9 by 2. If you are not getting an integer, you just write the number as it is. 9 by 2, it's not an integer value. I just written the number. Now, next thought process, divide by any prime number. Let's divide by 3. 3 by 3, it's 1. Can I divide 4 with 3? No, you're getting decimal value. I write the number like this. Can I divide 9 by 3? Yes, 3. So again, divided. The idea will be we have to get 1. I think we can divide by again 1. Sorry, 3. 1 divided by 3, decimal value. So that's 1. 4 by 3, decimal value. I write the number as it is 4. 3 by 3, that will be 1 here. Okay, again, for the divide, I can divide by 2. So here I will write the number as it is. 4 by 2, that will be 2. And here 1 by 2. Decimal value, I write the number as it is, again divide by 2. So it will be 1, 1, 1. So what will be the LCM? The product of all these numbers. It will be 2 times 3 times 3. That I can write it as 2 square times 2 times 2. So 2 we are multiplying 1, 2, 3. So it will be 2 cube times 3 square. What is that? That will be 9 times 8, 72. That will be the answer. Is this clear? Is this clear? So when you are getting it, LCM means you just keep dividing by prime number. You have to get 1. If the GCF means try to divide by a common number. Try to do the maximum. I hope it's clear, LCM and HCF to everyone. Please, can you confirm it? Please confirm it. Okay. I think we cannot go. One more concept actually there. Okay, how much time? 15 minutes only. Okay, let's do this one, this question. Okay, I will give you 30 seconds, 30 seconds or 1 minute. Do you know the answer? It's a numeric entry question. How many positive integers are factors of 100? Any idea? Okay, you cannot write manually all of it, okay? Like 1, 2, 5 and count it. There is a shortcut. That's what we are going to discuss it. I'll just discuss it faster here. Oh, 1 second. Okay, let's look at here. Let me put a question like this. Consider a prime number P, and let's consider the prime number as any number, 2, 3, 4, 4, no, 5 like this. Now, 2 square got how many factors? That's a question, right? So 2 square got how many factors? You can say 2 is a prime number, okay? So I can divide by 1, I can divide by 2 raised to 1, I can divide by 2 square. So there will be 3 positive factors. Correct or not? So for example, you write it as a prime number. Let's say P raised to 4, where I said P is a prime number. Consider for P as any value, 3 raised to 4, whatever that value. How many positive factors will we have it? 1. Then you write it as 3 raised to 1. Then 3 square, you have to get 3 raised to 4. 3 raised to 3, there will be 3 raised to 4. So the shortcut you have to remember, if p raised to n, but remember, if p is a prime number, how many positive factor will be n plus 1 positive factors? So 2 raised to 2, how many positive factors? I see the exponent is 2. So how many positive factors will be? N plus 1, 2 plus 1, that will be 3 positive factors. Clear? So 2 raised to 2, what is a positive factors? 1, 2 raised to 1, 2 square. 3 raised to 4, how many positive factors? I see the exponent as 4. So how many positive factors? N plus 1, that will be 4 plus 1, that will be 5 positive factors. These are the positive factors. Is this statement clear to everyone? Please confirm it. That's what it's written here. Please, everyone, please confirm it. A difficult question can be from here. Okay, what about 5 raised to 7? How many positive factors? 5 raised to 7, how many positive factors? Okay, 8. What about others? Please type it. Okay, first thing, look, is this a prime number? Yes, then I can say n plus 1, 7 plus 1, 8 positive factors. 4 raised to 3. Do not say 4 raised to 3. This will be 3 plus 1, 4 positive factors. No, this is wrong because 4, it's not a prime number. So the idea, we have to get it as a prime number. How can I do that? You can do prime factorization. Okay, now let's come back to a question. We will do this question. Look, the questions can be like this. How many positive integers are factors of 10? First thing, you write it as a product of prime numbers, okay? So it will be 5 times 2. Both of them are prime numbers. 5 raised to 1 times 2 raised to 1. Now you have to do things separately. If it is 2 raised to 1, how many positive factors? We know that that will be n plus 1. That will be 1 plus 1, 2 positive factors. Okay, good. What are these? 1 and 2 raised to 1. Same thought process. 5 raised to 1, how many positive factors? 1, and that's 5 raised to 1. So n plus 1, 2 plus, 2 positive factors. So it means I know 5 raised to 1 got 2 positive factors, and 2 raised to 1, how many positive factors? That will be 2. So it will be 2 times 2, that will be 4 positive factors. Clear? Perfect. That's it. Okay. Now, if the question is like this, 18, same thought process, you write it as a product of prime numbers. I can say 3 square times 2 raised to 1, right? 9 times 2 raised to 1. Now think about 3 square. How many positive factors? I know it's already a prime number. So it will be n plus 1, 2 plus 1, 3 positive factors. Okay, times 2 raised to 1, it's a prime number. Whatever that, exponents plus 1, 2 positive factors. Do not add, it's a multiplication. 3 times 2, 6 positive factors. Clear? Perfect. Now, Sai, why 5? 6, right? Do not add, Kumaran, do not add. It's a multiplication. 3 squared times 2 raised to 1. 3 times 2. How many positive factors? Times 5 positive factors. Clear? Okay. Guys, what will be the answer? 36. Then we'll go for 100. Faster. No. Let's do one question. Okay. We are late already. How many positive factors we have at 400? Just do this question. 36. It's easy. Anyway, you'll do it. 100 got how many positive factors? Write it as a product of prime number. Okay. Try. Break that 100 as a product of prime numbers. You can use the factor tree method or division method and type your answers. Correct. Move and try to think. You're right. 5 square times 2 square. Now look, 5 square got how many positive factors? N plus 1. Then you multiply out. Okay, Sai, look, I think maybe you're making a careless mistake. Okay, let's discuss it. 100 means I'm just using okay, factor. Okay, tree method. Let's use it. 25 times 4. Or 25, it's not a prime number, that will be 5 square. 4 means 2 times 2, 2 square. So 100, I can write it as the product of prime numbers, 5 square times 2 square. Now look, 5 square, if I look at here, 5 square, how many positive factor? N plus 1, 2 plus 1, 3 positive factor. Okay, times 2 square, how many positive factors? Exponent plus 1, 2 plus 1, 3. So 3 positive factors times 3 positive factors, that will be 9. Please do not add. You can think like this, it's multiplication, you have to multiply out. Over God, that will be 6. That is wrong because you are adding, it's a multiplication. Bhuvan, is it clear? Sai, is it clear why it's not 12? Okay. Okay, so we did almost all the questions except the properties of odd numbers and even numbers. Okay, maybe okay. Let's finish it anyway. Then you can solve the questions also. Now, look, you don't have to memorize all this thing. What is odd plus even plus odd, all this thing. Just think if what is the answer? Odd number plus odd number. What you have to do? Just take an easy expression. Odd plus odd. 1 plus 1. What you're getting? That will be 2. It's an even number. That's what you have to remember. What about odd number minus odd number? Consider two easy number, 3 minus 1. That will be even. That's it. Now, what about odd number times even number? Consider 3 and an easy even number 2. 3 times 2, that will be even, right? Even times odd times even, then even times even, that will be also even. So just use logic, you will get all of this, okay? Just a simple expression. Let's try to focus on the questions here. Let's look at the first question and type the answers. First, try to, okay. Leave 1 minute 20 seconds for this question. Okay, I'm getting an answer. Good, good. Let's wait for others. Please, yeah, you can use logic also. You will get the answer. This is just a media level question, okay? But I can show you difficult questions later. So that time, I think you cannot use like normal multiples of 6 and I think 10. Yeah, that time you have to use the division rule to solve that question. Okay, Gayatri here, if they're asking the multiples of 6 and 10, correct? Right? So all they're asking what is LCM of 6 and 10. Even you didn't understand that concept. I hope everyone understood. They are saying red light, right? Every 6 seconds flashes. So red light, if I write it, this will be 6 seconds, then 12 seconds, 18, that will be 24, 30, keep going like this, right? So that will be 36. And what about the blue light? That will be 10 seconds flashes, blue light. So it will be 10, 20, and 30. Now look at it, keep going like this. Okay, 40 and yeah. And they're asking when it will flash together next time. So when it is coming to common multiples, there will be common multiples 30, 60, everything. But remember, they asked next time. So automatically the answer will be 30. Is this clear? No, no, no. Gayatri, yeah, yeah, I do understand. What are the devices of, let's say, 100 or 200? No, they will not ask you like that. They will ask how many. Yeah, Gayatri was asking, will I get a question like this? How many? This is the question we discussed. How many positive integers are factors of 100? It will know that will be 9. We got it, right? They will not ask you what are the positive factors of 100. That is not the question. They will ask you how many positive integers are the factors of 100, or they can say how many integers are factors of 100. Okay. Now, I hope it's clear. Or if you understood LCM of 6 and 10, you can use ladder technique or division method. Division method, let's follow it. Okay, I try to divide by a prime number. So 3 here, then 5 here. Again, divide by a prime number, 3 by 3, that's 1. Again, 5. I divide by 5, that will be 1, 1. So what is LCM? The product of all these numbers, 2 times 3 times 5, that will be 15, 30. Is this question clear to everyone? Please confirm it. Can I go to the next question? Okay, good. Let's do this question. I hope everyone understood. It's an MCQ question. Select one or more answer choices. Maybe one answer is right, two or three. You have to mark exactly all the correct answers. Take your own time. I hope everyone can see the question. You can try hit and trial method, or you can use the direct concept. Okay, I will give you 1 more minute. Please type the answers. Let's wait for everyone. Okay. Bhuvan, you're right, but there are one, I think you missed one answer, Bhuvan. Maybe check it. It's a simple one. If you got that option, definitely you can pick the next one. Let's wait for 10 more seconds. Please, everyone, try to solve this question. You know that we just got 1 hour, right? So I have to discuss maximum number of questions. That's why I'm giving you 2 minutes. You will get this slide. Take your own time. Try to solve the question. If you have any doubt, you can ask me. I can explain it personally. Okay, Kaveri, you got A and C. Okay, let's try to discuss it. All I know, A less than B less than 0. What is A and B? Then negative numbers. I try hit and trial method. So what is the value of B? I have to take it maybe -1. Easy number. Let's take A as -2. Is this statement true? Yes. So I just assume A as -2 and B as -1. You can just use the concept and solve it. But here right now, I'm just trying hit and trial method. Now look, what is A minus B? That will be, you can say, -2 minus -1. You can see -2 plus 1. So that will be always -1. It's a negative number. They're asking positive. And it makes sense. It's a big negative number. You can see that minus negative number, that will be a small positive number. So the entire result will be negative. Clear? So option A is out. Someone, okay. Kaveri, do you understand why option A is out? Because they're asking the positive numbers. So A is out because you are getting it as negative. Okay, now what about B? Okay, now same thing, you can try hit and trial method. We assume A as negative, so -2 square, that's A square minus B square minus a -1 square. So positive number only 4. This is also -1 square, that's 1. 4 minus 1, you will get always positive. Or if I look at the concept, okay, you have to be comfortable with 3 expression A plus B square, A minus B square, then the third one, A squared minus B square. So I think next class I can explain it more. So A square minus B square, you can think A plus B times A minus B, right? So if I think A square minus B square, that will be A plus B times A minus B. What is A plus B? Both negative numbers plus negative number, that will be a negative number. We already discussed it, A minus B in the first statement negative. So this is negative, this is negative, right? Negative times negative, this will be a positive expression. So B will be the answer. Now, what about C? Okay, I think Bhuvan, I think. Yeah, so Bhuvan, look at this option C. A times B, right? What is A? Negative number. What is B? Negative number. Negative times negative, that will be positive, right? I hope you understood. You missed it. I think it's a careless mistake. What about A square B? You can just think about the sign. A is negative. What about A? That's negative, but negative square, that will be positive. Positive times negative, that will be negative. That's out here. Same thought process here. A square B plus A B square. Okay, B is negative, A is negative, but A square is positive. Positive times negative, that will be negative expression plus A, it's negative, and same thing, B square will be positive. So it will be negative. Negative number plus negative number, that will be negative number. So B and C. Okay. So I hope this question is clear. Look, third question, you will do it. I don't want to waste the time. Please try to do it as a homework. Um, okay, this is too easy. I will give you 1 minute, 20 seconds. Try to solve this question. It's not a difficult question. It's an easy question, I will say. Just read it. You have to just go through it. Satya, try. I think you got one right. You are missing one option. Okay. I got answers from 6 students only. I will just wait another 20 more seconds. Okay. So at least, yeah. Sakshi, look, there is a careless mistake with the D option. Check it. Why it is wrong. And you missed one option. No, no. Kiran, you missed one option. Check it properly. Harsh, you picked one wrong answer. You have to eliminate it. Okay, let's try to discuss this question. Okay. Now, I saw everyone got the answer, but look, there is one wrong answer is keep coming. So you will not get mark for that question. Okay. No partial mark. So look, please do it carefully. One student, right? And n is an integer. He made an equation 4n plus 3, and he said it's a prime number. So we have to disprove it. We have to make it is wrong. It's not a prime number. Okay. Which one will make it as prime number? Let's assume these are the values of n. That's a question, right? So if I substitute n as 1, what will be the answer? 4 times 1 plus 3. 4 plus 3, that will be 7. Is it a prime number? Yes. Prime numbers will be 2, 3, 5, 7, like this, right? We can say this statement is true. This is not our answer. When I substitute 3 here, 4 times 3, that will be 12 plus 3, 15. This is not a prime number. Yes. So when it is 3, you are getting it wrong. So you have to pick this answer B. Okay. Now I think someone marks C. Satya, look, if I plug in 4, so it will be 4n, right? 4 times 4, 16 plus 3, 19. 19, is it a prime number? Okay, 1 second. 1 second, 1 second. Okay, what about then why everyone got B and E? Let me check. Okay, 1 second. Why not C, guys? You have to disprove it, right? 4 times 4, 16 plus 3, right? Okay, Satya, 1 second. Let me check it. 1 second. What about the other option? This will be 4 times 6 plus 3, 24 plus 3, 27. It's not a prime number. Okay, D is what? Guys, most of you got B and T. Okay, look. 6 also, look, it's you have to get it wrong, right? If I plug in here, then I think most of you made a mistake. Whoever got B and this one, right? D, I think it's wrong. Look, 4 times 6, that's 24 plus 3, 27. So you have to pick this option. 1 second, I'm making a mistake, a careless mistake. What about C? C? Please type your answer. C. Is it right or wrong? So if I plug in here, I think the right answer will be B and D. So 4 times 4, 16 plus 3, that's 19, right? This is a prime number. Oh, okay, okay. Look, Satya, do you understand what was a mistake? We just complicated the question. Look, when I substitute here C, look, this is the equation. He said it's prime number. We have to disprove it. Means you should not get a prime number. Clear? That was a mistake here. So if I plug in 4 here, 16 plus 3, 19. Is this statement true? No, we have to disprove it. That's why this option is out. Satya, is this clear? You have to make it wrong. So when I plug it D, look, 6 times 4, 24 plus 3, 27. Is it a prime number? No, definitely you have to disprove it. So that's working. When I plugged it 7, 7 times 4, 28, 28 plus 3, 31. Is it a prime number? Yes. So it means this statement is true. So you have to check which statement is not true. So that will be B and T. Guys, I made a mistake. C is not the answer. Clear? Satya, is this clear? Harsh, I hope you understood why it's not option E. Satya and Harsh, could you please confirm it? Uh, Bharat, Sakshi, you got E. Trishti, you got E, right? That statement is true. Look, 4 times 7 plus 3. Is it a prime number? Yes. 28 plus 3, that will be 31. It's a prime number, right? I cannot divide by 3 or any number. So you have to disprove it. This equation is true. Definitely you cannot pick E. Clear? The correct answers are B and D. Please, can you confirm it? Everyone, whoever got BE or other options, please, others. Okay. Now, this is an easy question. I will give you 1 minute. Try to do the fifth question. Must be true means all the time it should be true. 2 more minutes, then we will be done with these questions. What is the answer for this question? Please type. Madhu, please think, is that statement always true? Alam, please try to think, is that statement always true? Must be true means all the time true. What about others? Please type the answers. Prove and check it. Okay. Okay. Now, look, you see another mistakes, right? Student used to think, okay, you got an expression. Look, minus m divided by 19, it's an even integer. Okay. Now, look, when you see negative m, don't think it's a negative integer. Clear? It can be positive also. Okay. They didn't mention what it is. Okay. It can be negative also or positive integers also. Unless they are not specified, do not think when I see negative, it will be a negative integer. We cannot say m is negative or m is positive. For example, if m is a positive number 2, what will be this expression? Negative 2, right? So it's a negative number. So what about if m is like a negative number, negative 3? Then you can say negative m will be negative times negative 3. That will be a positive expression. So please do not say m is negative or positive. Alam, is this clear? Madhu, is this clear? Why not option A? Okay, from here, look, if I simplify for m here, right? If I simplify it here, I have to multiply 19 both sides. So negative m will be, you can say, even number times 19. Think what it is. Is it even or odd? Even times odd number. You can take an easy number, 2 times 19. What will be the result? 38. All I know, negative m, that will be just an even expression. I can say all the time, right? What will be m? Doesn't matter, whatever it is, the m will be always, and if I divide with negative 1, in this case, negative 38, right? So it will be a just even number. Clear? Even integers. So what are the even integers? Negative 4, negative 2. It can be positive also, 2, 4, all this thing. So I cannot say m is a negative number, positive number. M is a prime number. I cannot say always. Sometimes it is true. No, not always. This statement is always true, right? Someone said C, that is wrong always, okay? So definitely E is the answer. M is an even integer. Is this question clear to everyone? Is this clear? Please confirm it. We just discussed only 5 questions, okay? I really wanted to discuss at least 7, 8 questions today. Look, these are difficult questions. Then from 6, 7, all of them are difficult questions. We didn't discuss it. 8 is easy. So you will get this file. At least try to do the questions till 11, okay? Look at this question. It's a difficult question and try to do it. So once you're done with that, you have to do it. It's a homework. At least try to solve the question up to 11. There are a couple of more questions. This is too easy. Even if you skip it, that's perfectly fine. If you have time, try to complete all the questions. At least if you don't have time, try to solve the 11 question. We'll try to discuss the numbers chapter, and tomorrow also we'll try to discuss cyclicity concept, rounding, and reminder concept. If there is any questions you have it, you can ask now. Otherwise, we will end the session now. No, no, no. Gayatri, in the exam, they will not ask like that. Okay, if you want, I can discuss an approach. Okay, they will not ask. They will ask, what is the total number of positive devices of 372? Okay, look, in the official guide, the questions also like this. Look, which of the following integers are divisible by 8? In the exam, they will not ask you like this. To practice, they have put the question like this. Clear? They will never ask. So if they're asking the LCM concept, they will ask like this, or the first question we discuss it. They will just frame this way. Okay? Is this clear to you? Okay, so that's it, guys, from my side. I hope you don't have any doubts. We can see tomorrow. Try to solve the question till 11. If you didn't get the slide, please ask the admin. Okay, they will send you the link. Ma'am, that's it from my side. Can I end the class?
Yes, sir. Just a
Okay,
second.
yeah,
Thank you.
sure.
Hi, guys. I hope you all had a great session. Um, yeah, so if you have any queries that you want to ask me, then you can put in the chat box. Otherwise, the session for today is over. And thank you for joining again. And do register for the webinar that I share the link of. Okay, guys. Okay, great. Thank you, guys. Thank you. I'll see you guys tomorrow then. Okay, bye. Good night.